Hello everybody. Today will be few problems based on mains and advanced standard. First problem. A particle is projected from point A with a velocity u root 2 at an angle of 45 degrees with horizontal. So you can observe that a particle is projected with a velocity u root 2 at an angle of 45 degrees with horizontal. It strikes the inclined plane at right angles. So you can observe that the particle will strike the inclined plane. Particle will strike the inclined plane at 45 at 90 degrees. Right angles means 90 degrees. Find velocity of the particle at the time of collision. So when particle strikes here, we are supposed to find what is the velocity of particle. So particle strikes means here the velocity will be right angles. Velocity will be right angles in this direction, right angles to the inclined plane, and it will be in this direction. Okay, now this velocity I'll resolve into two perpendicular components, horizontal component and vertical component. You can observe that in this right angle triangle, this angle is 60 degrees and this is 90 degrees. Therefore, this angle will be 30 degrees. It will be 30 degrees. Therefore, this angle will be again 60 degrees. Therefore, this side it will be V cos 60 degrees and this side it will be V sin 60 degrees. This side will be V sin 60 degrees. Okay. Now we know that in a projectile, horizontal component of velocity remains same throughout the motion. So horizontal component of velocity everywhere it will be u cos theta only. So here u is given as u root 2 cos theta. Sorry, u root 2 cos theta. So this velocity will be same throughout the motion. Wherever you consider the point, its velocity will be horizontal component of velocity will be constant throughout the motion in projectiles. Therefore, at this point, I can assume that V sin 60 degrees is equals to u root 2 cos 45 degrees. Okay, so this I can write it as V sin 60 is nothing but root 3 by 2. That's equals to u into root 2 into cos 45 is 1 by root 2. So root 2 cancels. So we'll get V is equals to 2u by root 3. V is equals to 2u by root 3. So this is the velocity with which the body touches the inclined plane at this point. So here the main logic is horizontal component of velocity remains same throughout the motion for a projectile. So horizontal component of velocity is nothing but u cos theta. So in place of u, you are having u root 2. In place of theta, you are having 45 degrees. So here you will get u root 2 cos 45 degrees. So here at this point, horizontal velocity is equals to horizontal component of velocity is v sin 60 degrees. So we can conclude that this v sin 60 degrees and u root 2 cos 45 degrees must be equal. If we equate them and simplify, we'll get the value of final velocity with which the body touches the ground. Okay, we will proceed for next problem. A uniform rope of linear density lambda and length L is coiled on a smooth horizontal surface. So first we have to know what is meant by linear density. So linear density, which is denoted as lambda, is nothing but mass per unit length. mass by length, we call it as linear density. So this implies mass of the chain is equals to lambda L. Mass of the rope is equals to lambda L. Cross multiplication will get this one. Okay. Now initially entire rope is on horizontal ground, is on horizontal surface. Therefore, its initial potential energy, will be equals to 0. And because the rope is at rest, we can say that initial kinetic energy is also equals to 0. Okay. Now, rope is lifted up with a velocity v. So one end of the rope is holded in the hand and it is lifted up with a constant velocity v. Now we are supposed to find average power applied by the pulling force for the entire rope just off the ground. So what is the average power required? We are supposed to find. Okay. Now, final kinetic energy is equals to half mv square. So in place of mass, we are having lambda L into v square. Velocity is v square. Similarly, final potential energy is equals to mgh. So in place of m, we are having lambda L, g. Height, we are supposed to consider location of center of mass of the rope, vertical rope. So rope is of length L, so its center of mass will be lying at L by 2. So in place of H, I will be taking L by 2. So this is the final potential energy. Also, time taken for lifting the rope, for lifting entire rope, time taken, I am using the relation speed is equals to distance by time. Speed is equals to distance by time. So I can write time is equals to, in place of distance, I'll take length of the rope, and speed is nothing but v. Speed with which it is nothing but v. Okay. Now average power, I can write average power is equals to change in energy by time. So this I can write it as average power is equals to change in energy. Initial energy is nothing but 0. Potential energy and kinetic energy is 0. And final energy is nothing but, I can write half lambda L v square plus, that is kinetic energy, and final potential energy is lambda L g into L by 2. Whole thing divided by time is nothing but L by v. Time is nothing but L by v. This we got it here. So this we must simplify. We will simplify it in the next page. So I can write power, average power is equals to lambda L So previous step we will be writing once again, lambda L v square divided by 2 plus lambda L g L by 2 whole thing divided by L by v. This is the previous step, we had written it as it is, I am writing now. Now this we will simplify. That's equals to, so this I can write it as lambda L v square by 2 plus lambda L square g by 2 whole thing into, I can write this as v by L. I can write that as V by L. Okay. We had used capital letter throughout. So everywhere we'll be using the same notation. So we will be using capital L only. Okay. Now this I can write it as that's equals to cross multiply. So here L, this L and this L will cancel off. So you'll get lambda V cube by 2 plus lambda, again one L will, this one L and this L cancel off, you'll get LGV divided by 2. So this is the answer you'll be getting in this case. This is the answer you'll be getting in this case. So let me go back to the entire problem once again. So first we'll start with linear density. Linear density is nothing but mass of the string by length of the string, a mass of the rope by length of the rope. We call it as linear density. So from which we can find mass is equals to lambda into L. We'll get a lambda into L. Initially rope is at ground, horizontal ground. So initial potential energy will be 0, and initially rope is at rest. So initial kinetic energy is also 0. Now rope is pulled up with a velocity v. So kinetic energy is equals to half mv square, but mass is equals to lambda L. Therefore, I can write half lambda L into v square. Potential energy equals to mgh. So in place of m, we'll be writing lambda L, g, height. Height we must consider center of mass location. So total length of the rope is L. So its center of mass will be lying at L by 2. So in place of h, we'll be writing L by 2. So total time to lift the entire rope is given by the formula speed is equals to distance by time. So speed is nothing but v, distance is nothing but length of the rope L, and time I'm denoting as t. So I can write time is equals to L by v. Now average power is equals to net change in energy by time. So net change in energy, this is the final energy, potential energy, final potential energy plus final kinetic energy, and this is initial potential energy and initial kinetic energy. Subtract, you'll get this one. Time, I'll write it as L by v. So this we must simplify. Next place we'll be doing simplification. So this on simplification will get the final answer. Hope it is clear. Okay, we'll go to the one more problem. A bead is free to slide down a smooth wire tightly stretched between points A and B. So this is a bead which can slide along the string AB. Along the string AB, it can slide. Bead starts at A and at the highest point of the circle. You are supposed to find velocity of bead arriving at B is proportional to dash, and time of arrival at B is proportional to dash. Which one is the correct answer? Among 4 options, 2 will be correct. It's a multiple answer type of question. So which 2 are correct? We are supposed to identify from these 4 options. From these 4 options, we are supposed to identify which 2 are correct. Okay. So let me assume that R is radius of the circle. So this distance is nothing but radius R. So this is also radius R. Radius R. So diameter will be 2R. Diameter will be 2R. Now on the bead, acceleration due to gravity will be acting in downward direction. G will be acting in downward direction. Now this angle is theta, same straight line. With vertical, it's making angle theta. Therefore, this angle must also equal to theta. So naturally, this direction acceleration is g. Therefore, in this direction, acceleration must be equals to g cos theta. Acceleration will be g cos theta. Okay. Now, we want to find length of the string AB. We want to find length of the string AB. For that, join this point. Now, in this semicircle, this we got a right angle triangle. We got a right angle triangle. So here I'll apply cos theta. Cos theta is equals to adjacent side by hypotenuse. Adjacent side by hypotenuse. Okay, so that's equals to adjacent side for this triangle is nothing but AB, and hypotenuse is nothing but diameter, that's equals to 2r. Therefore, we'll get AB is equals to 2r cos theta. AB is equals to 2r cos theta. Okay. Now we'll use the relation v square minus u square is equals to 2as. We'll use this particular relation. So v square we are supposed to find, we are supposed to find. Initial velocity is 0 because beat starts from rest. That's equals to 2. In place of a, we got g cos theta into, in place of distance is nothing but AB. AB is nothing but equals to 2r cos theta. 2r cos theta. So this will get v square is equals to 4gr cos square theta. 4gr cos square theta. Therefore, we can draw the conclusion that v is equals to 2 root gr into cos theta. If you take square root on both sides, we take square root on both sides, so we'll get v is equals to 2 root gr cos theta. So this implies v is directly proportional to cos theta because 2 root gr is constant. Therefore, among the four options, first option we are having velocity is proportional to cos theta. So this first option is correct, second option is wrong. First option is correct, second option is wrong. Now we are supposed to find time of arrival of bead from A to B. What is the time of arrival? We'll solve it in the next phase. Now we know that acceleration is equals to change in velocity by time, v minus u by t. Acceleration is equals to change in velocity by time. So this implies, I can write this as time t is equals to final velocity is v, v starts from rest, so initial velocity is 0, by acceleration is a. So this we will substitute the values. So just now we had determined the value of v. So v we had determined as 2 root gr into cos theta. And acceleration we got it as g cos theta. Acceleration we got as g cos theta. So cos theta cancels. So this you will get it as 2 into root g will cancel off. So you'll get root r by g. So you can observe that here there is no theta. In the final equation we are not having any theta. Therefore we can conclude that t is independent of theta. T is independent of theta. Independent of theta. So this is a conclusion we'll get. So in the last option, we got it. This one is wrong and this one is correct. So time to arrive at B is independent of theta. That's correct. Okay, let us revise once again. So a bead starts sliding from A to B along this string. String makes an angle theta with the vertical. Now, in this circle, this radius of circle, I'll take it as r. So diameter will be equals to 2r. Now, acceleration will be nothing but acceleration due to gravity, which is acting vertically downward direction. So you can observe that this is making an angle theta with the direction of string. Therefore, the acceleration in the direction of string is nothing but g cos theta. So acceleration in the direction of string is g cos theta. Okay. Now, in the semicircle, a right angle is formed. So if we find cos theta is adjacent side by hypotenuse, which is nothing but adjacent side in this one is nothing but adjacent to theta is nothing but AB, and hypotenuse is nothing but AC. So AB by AC. AC is nothing but 2R. Cross multiply, we'll get AB is equals to 2R cos theta. Now we'll use V square minus V square is equals to AS. So beat starts from rest means U is 0. Final velocity is V. Acceleration is nothing but G cos theta. And distance traveled is nothing but AV, which is equals to 2R cos theta. Simplify, we will get that V is directly proportional to cos theta. So option 1 is correct. Next, we want to find time taken for B to travel from A to B. For that, again I am using this concept. V is equals to root 2 GR, 2 root GR cos theta. This also I will be using in the next page. So next page we'll start with acceleration. Acceleration is equals to change in velocity by time. Rate of change of velocity or change in velocity by time. So time is equals to change in velocity. Initial velocity is 0 for bead and final velocity we are taking as V, and acceleration is nothing but A, which is equal to G cos theta. And velocity we had determined as 2 into root GR cos theta. We can observe that this cos theta will get cancelled off. So you'll get T is equals to 2 into root RG, R by G. So this equation, there is no theta term. Therefore, time is independent. Time to travel from A to B is independent of theta. That is the conclusion. Hope all the three problems you are able to understand clearly. Okay. We will meet in the next class. Thank you.